Math 3 Summative Review for Unit 8, which is Module 4, Part 1, Trigonometric Relationships. Number 1. Given the function f of x equals cosine x, describe the transformations to make n of x, which equals negative cosine 3x plus 2. So the negative sign in the front is your reflection over the x-axis, just like it always is. The 3 that's being multiplied by the x, since that's inside the parentheses, that's going to be a horizontal compression by a factor of a third. Because remember, the horizontal transformations are always the opposite of what we think they should be. So that 3 is the b value. So if the b value is greater than 1, it's actually a compression as opposed to a stretch. So horizontal compression. And then it's by a factor of 1 over b. So since b is 3, it would be by a factor of 1/3. The plus 2 in the back is not in the parentheses, so that's a vertical translation up 2 units. On number 2, the 1/2 in the front would be a vertical compression because the a value is in between 0 and 1. Inside the parentheses, those are always our horizontal transformations, and they're always the opposite of what we think they should be. So since it's a minus 90, that would be right 90. So a horizontal translation right 90. And then in the back, that's another vertical transformation since it's outside the parentheses, so you would go down 6. So vertical translation down 6. Looking at number 3, we have a periodic function, and we're going to find all the key features. So the period is how long it takes the graph to complete one full cycle before it starts repeating itself. I feel like on this particular graph, it might be easiest to go from this peak right here to this peak right here, because you're doing one full cycle before the graph starts doing that same movement again. So I go with the largest x value of 7 minus the smallest x value of 1. So the period would be 6. For part B, the maximum, they're just talking about the largest y value on the graph. So right here, the largest y value would just be at 1. For the minimum, they're just looking for the smallest y value, so that'd be negative 5. Amplitude is 1/2 times the absolute value of the maximum minus the minimum. So we have 1/2. The max was 1 minus the minimum was negative 5. So that's equal to 1/2 times the absolute value of 6. And the absolute value of 6 is positive 6. So 1/2 times 6 is going to be just 3. For midline, it's y equals the maximum plus the minimum divided by 2. You're basically just taking the average because you want the line that goes right through the middle. So your max is 1, your min is negative 5, and then divide by 2. So negative 4 over 2 is negative 2. At the end of a midline question, make sure it's super obvious that it's y equals whatever the number is. If you go over to the graph, y equals negative 2 would be right here. That should be right through the middle. So it should be the same distance from the midline down to the lowest value as it is from the midline up to the highest value. So sure enough, that's 1, 2, 3 units. And then going from the midline up, 1, 2, 3 units. And that distance from the midline up to the top or to the bottom is also known as the amplitude, which sure enough, there it is. Amplitude is 3. On number 4, when we try to get the period, it doesn't hit super nicely And so we're just going to kind of approximate it the best we can. So you're going to have a decimal, and that's okay. So I'm going to start in the middle. I'm going to start with an x value of 0. So I'm going all the way up, all the way down, and then back to the middle. So this is one full cycle before this graph starts repeating itself. So as far as this largest x value, it's really hard to tell for sure what it's at. If we look at our scale, each tick mark is 0.5. So we know that this x value right here has to be a little bit less than 6.5. So maybe we could go with like 6.3 maybe. So 6.3 minus 0, because 0 would be this x value over here, is just 6.3. And on a summative, if we gave you something like this, I would have to grade it pretty leniently. I'd probably accept anything from, 6.2, 6.3, 6.4. Probably any of those would be fine. For the maximum, we're looking at the highest y value. So right up at the top here, this is a y value of 1. For the minimum, we're down here at a y value of -1. Amplitude is 1/2 times the absolute value of the max minus the min. So we're getting 1/2 times the absolute value of 1 minus -1. So remember that double negative turns into a positive. So 1 plus 1 is 2. Absolute value of 2 is just 2. So 1/2 times 2 equals 1. So our amplitude is going to be 1. Midline is when you average your max and your min. So max plus min divided by 2, which is 1 plus -1 divided by 2, which is going to get us 0. And make sure it's super obvious at the end. The answer is not just 0, but it's y equals 0, because it's the equation of this line right here. So midline cuts through the middle, and it's the same distance from the midline to the top as it is from the midline to the bottom. So it's a distance of 1 on this particular problem, and that matches our amplitude, which is also 1. Working alone, Adam can harvest a field in 16 hours. Dan can harvest the same field in 13 hours. How long would it take them if they worked together? So the next 3 problems are those work problems. So Adam can do one field in 16 hours. So I like to do the number of jobs divided by the time times the time it takes for them to work together, which I'm going to call X in this particular problem. Dan can do that same job in 13 hours. So one job in 13 hours times X, and then equals the total number of jobs. So total number of jobs is just the one field that they're going to work on together. So there's our initial setup. As far as a least common denominator goes, we would want to use the least common multiple of 16 and 13. So multiples of 13 are when you're just counting by 13. Multiples of 16 are when you're just counting by 16. Honestly, since those numbers are both kind of on the big side, we could just use any multiple of 16 and 13. I'm going to do whatever 16 times 13 is, which if I type that into my calculator, it's 208. So I'm going to use that as my least common denominator rather than sitting here and listing out all the multiples of 13 and all the multiples of 16. I'm just going to go with that. It'll still work. We just might have to... Oh yeah, it'll still work. We don't have to worry about reducing at the end. It'll all work out in the end. Just as long as we're getting rid of the fractions. Like the whole point of picking a common denominator and multiplying it out is to get rid of all of the fractions. So in that first one, 208 divided by 16 is 13. So I'm going to change this to a 13 and cancel out the 16 in the bottom. So in that part, I'm left with 1x times 13. And then in the next one over, the next fraction over, 208 divided by 13 is 16. So the only thing left in the second fraction is 1x times 16. And then in the back there, 1 times 208 is 208. And then we'll just solve like normal. So we have 13x plus 16x equals 208. 13x plus 16x is 29x. And then divide. And on all these problems, we didn't really give you rounding directions. I typically like to round to the nearest hundredth, But since it doesn't have directions, I would be very lenient when I would be grading this as far as where you round to. So I'm going to go to the nearest hundredth, and I get 7.17. And then we want to have the correct units. So since we're talking about time, if I look back in the problem, everything was in hours. Number 6, Amy can do 1 job in 4 hours. Working together, Amy and Ted can complete 3 jobs in 8 hours. How long would it take Ted to do 2 jobs working alone? So Amy can do 1 job in 4 hours. And then we're going to need a time, but we'll get to that in just a second. Working together, 3 jobs in 8 hours. So I'm going to do 8 here, and then plus Ted, we're looking to see how long it takes him to do 2 jobs in how many hours. So 2 jobs in a mystery amount of time. And then times 8, the time it takes for them to work together, equals the total number of jobs. So a total number of jobs they could complete working together. So they could do 3 jobs working together. So that total is going to be 3. As far as a least common denominator goes, there's a 4 and there's an x. So our least common denominator is just going to be 4x. So we want to multiply all the fractions by 4x, or I should say all the terms in the equation, by 4x in order to cancel out all the fractions. So for that first fraction, 4 divided by 4 cancels, and you're left with the x up top. So you have 1 times 8 times x from that first fraction. Second fraction over, the x and the x cancel out. So you have 2 times 8 times 4. And then 3 times 4x is 12x. And then we should be able to just solve like normal from here. So 8x plus 2 times 8 times 4 is 64 equals 12x minus 8x minus 8x. Slide this over here. So 64 equals 4x. Divide by 4. Divide by 4. X equals 16. So 16 hours for Ted to do 2 jobs working alone. Number 7, Jenny can paint 3 fences in 4 hours. Susie can do 2 fences in 5 hours. If they work together, how long would it take them to paint 8 fences? So this is more similar to the first one for the work problems. So Jenny can do 3 fences in 4 hours. So it's the jobs per time. And then Susie can do 2 fences, so 2 jobs in 5 hours. And then how long can they do 8 fences if they're working together? So for the total jobs, we want 8 fences. And then we're just missing the x. X is the amount of time it takes them to do the jobs working together. So we put an x on both of the fractions. For a least common denominator, let's go with 20. So we're going to multiply everything by 20 to cancel out all of our fractions. So in that first part, we have 20 divided by 4 reduces to 5. In that second fraction, 20 divided by 5 reduces to 4. So then all we have left in that first fraction is 3x times 5. And then in that second fraction, 2x times 4. And then in the back, 8 times 20 is 160. And then we just solve like normal. So 15x plus 8x equals 160. 23x equals 160. Divide. And we get, nice ugly decimal. I'm going to round to the nearest hundredth. So 6.96, and I need my units, hours. So that's how long it should take them working together, approximately. Number 8, parts A and B, we have our radical equations. So on both of those, we need to isolate the radical first. So we have to isolate that in part A, and we have to isolate that in part B. So on 8A, we want to get that highlighted purple part all by itself by doing order of operations backwards. So I have to subtract 8 from both sides first before I do anything else. So I get 2 times square root of x minus 3 equals 12. And then I want to get rid of that 2 that's being multiplied. So to undo multiplication, do division. So then you get square root of x minus 3 equals 6. Now that the square root's all by itself, now we can go ahead and undo the square root. So in order to undo a square root, we want to square it. And whatever we do to one side of the equation, we have to do to the other side to keep it balanced. So square root of, that cancels out. So square root of x minus 3 squared cancels out to just x minus 3. 6 squared, remember that's 6 times 6, not 6 plus 6. And then we're going to add 3, and we should be good to go. Something we often forget to do with radical equations is check. We might have to throw out that answer. It might be an extraneous solution. So we take our answer, we go back to the original equation, and we just plug it in for x, simplify both sides, and see if it actually simplifies down to a true statement. So on this one, I think we're going to be good. Yep, because 12 plus 8 is 20. 20 equals 20. Yes, it does. So x equals 39 does work. We don't have to throw out the answer. For part B, the highlighted purple part is already all by itself, so we don't have to isolate the radical because it's already done. So now we get to jump to the step where we're going to square both sides. So squaring the square root leaves you with just x plus 3, and then squaring x plus 1 means we have to write x plus 1 times itself, and then we're going to have to FOIL it out. So first times first is x times x, which is x squared. Outside times outside is x times 1, which is x. Inside times inside is 1 times x, which is x. And then last times last is 1 times 1, which is 1. So then let's combine our like terms on the right side. X plus x is 2x. And then since we have x squared terms and x terms, we want to get everything to one side. So I'm going to subtract x from both sides, and I'm going to subtract 3 from both sides to get everything on one side. So x squared plus x minus 2. Since this is a basic trinomial, I want to try to factor. So what two numbers multiply to -2 and add to +1? Should be 2 and -1. Set each factor equal to 0 and solve for x. So we're getting -2 and 1. Now remember, we can't stop here. We need to check and see if one of these answers or both of these answers are extraneous solutions. So I'm taking -2. I'm going to check that one first. Wherever I see an x in the original equation, I'm going to plug in a -2. So then I get 1 equals -1. Well, that's not true. 1 does not equal -1. So I actually have to cross out that answer because it's an extraneous solution. Let me check the other one. So I'm taking a 1 and I'm plugging it in for x in the original equation. So square root of 4 is 2. 2 equals 2. Yep, that's true. So x equals 1 does work. For C and D, these are rational equations. So we want to get least common denominators, and we also want to jot down domain restrictions in case we have to throw out an answer at the end because it happens to be a domain restriction. So on letter C, n cannot be equal to 0 because if it was, then 2 times 0 would be 0 and 8 times 0 would be 0. And we're not allowed to divide by 0. So we're going to cancel that out. For a least common denominator, we want to use the least common multiple of 2 and 8. So multiples of 2 are just counting by 2, and multiples of 8 are just counting by 8. So basically, least common denominator is going to be 8n, because the least common multiple of 2 and 8 is just 8. So now we're at the point where we want to multiply every term by the least common denominator. That way we'll be able to get rid of all the fractions. So I'm going to multiply everything by 8n. So with that first fraction, when I go to divide, 8 divided by 2 is 4, and then n divided by n cancels out. So in that first fraction, I have a 4, and then don't forget to put the n minus 2 in parentheses. Next fraction over, 8n divided by itself cancels out completely, so we're just left with 3n minus 18. And then that last term, 1 times 8n is 8n. And then we should just solve like normal from here. So 4n plus 3n is 7n. Negative 8 and negative 18 should be negative 26. And then again, just keep solving. So subtract 7n from both sides. And we get n, and then that's it. Double check and make sure you don't have a domain restriction at the end. So n equals negative 26 is not a domain restriction, meaning yes, we can keep it as an answer. If it happened to be the same as the domain restriction, we would have to cross it out and we would say that there's no solution to this equation. All right, last one. So on letter D, for our domain restriction, x cannot be equal to 0, because if it was, the denominators would be 0, and we can't divide by 0. Least common denominator is just going to be 3x. So we're going to multiply all of the fractions by 3x in order to cancel out the fractions. So everything's getting multiplied by 3x. So that first fraction, the 3x divided by 3x, cancels out completely. The second fraction, the 3x divided by 3x, cancels out completely. And then that last fraction, the x and the x cancel out, so there's a 3 times 3 left over in the numerator. And then solve like normal. So x plus 3 equals 9. Subtract 3 from both sides, x equals 6. And then that is not our domain restriction, so we are good to go. That is an answer.